Hi, this is Eddie, and today I'm going to use the TI-36 Pro to solve a quartic equation. What is a quartic equation? It's a fourth degree polynomial. But if I try to solve the quartic equation directly through the polysolve feature, which is accessed by second cosine key, I find that the polysolver offers second degree equations and third degree equations, not fourth degree. So we're going to need to set up a strategy to solve for quartic equations. Okay? So here is our strategy. We're going to use the calculator's general solver to find a root, and we're going to call this root R. And then we're going to reduce the polynomial from a quartic to a cubic. So by synthetic division we get this general form where capital A is equal to A4, capital B is equal to A4 times R plus A3, capital C is equal to A4 times R squared plus A3 times R plus A2, and capital D is equal to A4 times R cubed plus A3 times R squared plus A2 times R plus A1. Once we get capital A, B, C, and D, we then can use the polynomial feature on the TI-36X Pro to get the other roots. Let's take an example. 2x to the fourth power minus 3x cubed plus 2x squared minus 2x plus 1 equal to 0, and we need to find the four roots. First of all, let's label the coefficients here. A4 is equal to 2, A3 is equal to negative 3, A2 is equal to 2, A1 is equal to negative 2, okay, and A0 is equal to 1. So the first step is to invoke the solver to get the first root of this quartic polynomial. So I'm going to hit second the sign key, and if it doesn't have an equation, the 36X will ask you to enter an equation. I went ahead and typed in the equation: 2x to the fourth power minus 3x cubed plus 2x squared minus 2x plus 1 is equal to 0. So we have the correct equation. I'm going to hit enter. It's going to ask you for a guess. I'm going to guess 0. Hit enter again, solve for x, and we're going to get an answer in a few moments. It tells us that the answer is 0.73898. I am going to select quit now and press enter. And see this variable key, which is above the store key here? Pressing this variable key cycles through the 8 available registers: X, Y, Z, T, A, B, C, D. Okay, so I'm going to clear that, and if I press the variable key once, I get X, and I hit enter, I get that root. I get 0.73898, 3622, the root I just solved for. Now I can use this information to get the coefficients for my reduced cubic. Recall that capital A is equal to A4, capital B is equal to A4 times R plus A3, capital C is equal to a4 times r squared plus a3 times r plus a2, and capital D is equal to a4 times r cubed plus a3 times r squared plus a2 times r plus a1. And for the problem we are working with, a4 is equal to 2, a3 is equal to negative 3, a2 is equal to 2, a1 is equal to negative 2, and a0 is equal to 1. So let's figure out where our coefficient is going to be using the TI-36X. I'm going to use x as my r. So we'll start with a first. So a is pretty simple. It just basically is 2. Hit the store key, and I need to hit the variable key 5 times. 1, 2, 3, 4, 5. That brings up a. I hit enter, and a is stored into the calculator. We're going to do the same thing for the other 3. Here's b. In this case will be 2x minus 3, store variable key 6 times. 1, 2, 3, 4, 5, 6. C. 2x squared minus 3x plus 2. Hit the store button. Variable key 7 times. 1, 2, 3, 4, 5, 6, 7. Hit enter. Last one for D. 2x cubed minus 3x squared plus 2x minus 2. Store variable key 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And now we have A, B, C, and D stored. I'm going to go ahead and go into the polynomial solver, which is accessed by hitting second and the cosine key. Select option 2. And note, one of the benefits of storing the proper variables, if I can just exit out of here just a second, note that you have ax cubed plus bx squared plus cx plus d is equal to 0, and the calculator takes the values from a, b, c, and d. So I can just hit enter, enter one more time, enter one more time, once more, solve is highlighted, press enter. I found out that one of the roots is 1. Scroll down, and the next root is about negative 0.1149 plus 0.81383 times I. Scroll down again, so I have another root, negative 0.11949 approximately. Scroll over to negative 0.81383 times I. So my 4 roots of the quartic polynomial is 1, approximately negative 0.11949 plus or minus 0.81383 times I, and the x from earlier, 0.73898. That is how to use the TI-36X Pro to solve a quartic equation. One word of caution. The quartic equation has to have at least one real root for this process to work. I hope you find this video helpful. Thank you very much.